Welcome to The Explainer. Today, we're diving into one of the biggest headaches in AI development: how to get an AI app from a cool prototype to something that actually works in the real world without it all falling apart. The secret sauce? It's a discipline called context engineering, and it's really what separates the pros from the hobbyists.
Look, if you're a developer, you have definitely felt this pain. You hack together a proof of concept, and in your little sandbox, it's magical. It works perfectly. But the second you try to scale it or show it to a real user, it just shatters. It's super frustrating, and today, we're going to look at exactly how to fix it.
You know, this whole thing even has a name now: vibe coding. It's that awesome feeling of power you get when you can whip up an app in minutes just by talking to an AI. The problem is, what you get is usually a house of cards. So in this explainer, we're going to ditch that and learn how to build a skyscraper instead. Okay, so let's get right into it. What is context engineering? This is the professional discipline that's designed to take us beyond those flimsy vibes and into truly robust, intelligent systems.
Now, you might be thinking, hold on, isn't this just a fancy new term for prompt engineering? And that's a totally fair question. But nope, it's not. See, prompt engineering is all about tweaking one specific phrase to get one specific better output. Context engineering is, well, it's bigger. It's a whole system. It's about giving the AI its entire universe of information, examples, rules, knowledge of your code base, all before it even starts working.
And this right here is the perfect analogy to make it all click. The large language model, the LLM, that's your CPU. It's the raw processing power. But the context window, that's the RAM. It's the AI's short-term working memory. And just like with a computer, the better the data you can load into that RAM, the more powerful that CPU becomes. So this context window, this working memory, is everything. It's the entire game. Everything the AI knows about what it's supposed to be doing right now is sitting there. So the job of a context engineer is to become the master of this space, to decide exactly what goes in, what comes out, and when. If you get that right, you get AI that just works.
But here's the trick. That working memory, that RAM, it's not infinite. And if you just jam it full of junk, the whole system will absolutely grind to a halt. So the real question for an engineer is, how do you tame that context window? Because when that window gets messy, things break in very predictable ways. First, you get context poisoning. That's when one tiny hallucination, one little error, gets stuck in the AI's memory and just keeps getting repeated, corrupting everything else. Then there's context distraction, where the AI gets so bogged down in the details you gave it that it forgets what it was supposed to do in the first place. You've also got context confusion, which is just feeding it too much irrelevant stuff, leading to terrible results. And maybe the worst one is context clash, where you give it conflicting instructions and the whole system just crashes.
So how do you stop all that from happening? Well, with an engineer's toolkit, of course. You've got 4 main strategies. To stop hallucinations, you use RAG, to pull in only the exact external knowledge you need. To fight distraction, you use pruning, to surgically remove any information that isn't relevant. To give the AI a long-term memory without bloating the context, you use offloading. And to prevent those nasty context clashes, you quarantine different jobs into their own little sandboxes.
Okay, so we've got these cool strategies like RAG and pruning, but how do you actually use them together in a real project? For that, you need a blueprint. Let's talk about the Product Requirement Prompt Framework, or PRP, which is designed to do exactly that. The creator of this framework, an engineer who goes by Rasmus, put it perfectly. He said the whole goal is to create the minimum viable packet of information an AI needs to ship production-ready code on the very first try. I mean, just think about that. No more spending days and days debugging.
So what's inside this magic packet? Well, it's actually 3 things. First, you have the PRD, the product requirements. That's the what. Next, you add Codebase intelligence, so the AI actually understands the code it's working with. That's the where. And finally, you give it an agent runbook, a step-by-step instruction manual. That's the how. What, where, and how, all packaged up and ready to go.
And the workflow is really systematic. First, a human developer defines the plan.
Then you let an AI assistant do the heavy lifting of gathering all that context and building the full PRP packet. That part's automated, but that leads us to the most important step of all.
And that step is validation. You never, ever trust the AI blindly. A human developer has to review the AI's plan, that PRP packet, before it gets executed. And then they have to review the final code too. This human-in-the-loop oversight is the non-negotiable step. It's what separates professional engineering from vibe coding.
Now, this is about more than just writing better code. When you start adopting a discipline like context engineering, it has way bigger implications for how we build the future of AI. So why does this all matter? Simple. The payoff is massive. When you invest that time up front to really engineer the context properly, you can see up to a 10x improvement in your development process. Seriously, 10x. Think of all the hours you won't spend debugging, refactoring fragile code, or just scratching your head wondering why the AI did what it did. This is a real shift from trying to work faster to actually working smarter.
Of course, having this much control introduces some pretty serious engineering challenges. As a context engineer, you're now the architect of the AI's world. That means you have to build in security to stop attacks like prompt injections. You have to design for fairness, making sure you aren't feeding it biased data. And you have to build for transparency, so the system can actually explain itself, which is crucial for real debugging and validation. And this all leads to a final, pretty provocative thought. As AI gets woven into more and more of our jobs, the ability to give it clear, effective context is becoming a universal skill. So, if context really is the new code, does that mean we're all on our way to becoming context engineers? Thanks for joining us on The Explainer.